All right. So we've just gone through and looked at time-biased gain as an example of how we can model user behavior and make a prediction about their performance using a search engine. And again, we get to then use that with a test collection to make predictions of user performance. And then we can compare different search engines to each other and try to figure out which one is working better. We can use it to optimize parameters and so forth and so on. And a really cool thing about it is it's actually predicting a human understandable number, which is the average number of relevant documents that we think people are going to find using that search engine. It's, it's 3.2 versus 2.1. Hey, the one that found more, they're able to find, at least a relevant document more or so on average. That's really good. Okay, so it can put it into very human terms. Now, one of the things is we talked about it as a notion of gain. And the notion of gain there is something that, again, I noted is definitely additive. We get to sum it up. I'm finding number of relevant documents. There are other cumulative gain measures. Okay. The most widely used of all, and it's very widely used, it's a good measure, the most widely used is known as NDCG, which stands for Normalized Discounted Cumulated, but probably a lot of people actually say cumulative gain. All right, so what is this measure? Well, it's basically a cumulative gain measure. So these things have a general form of this. I'm kind of doing this out of order, my apologies. I'm supposed to tell you this after I show you this formula. 1 over n, where this is n is a normalization factor. Which is designed to make all scores across all search topics fall into a range of 0 to 1. All right. Then it is again a summation where we go from rank 1, so this is our rank, to, just for symbolic purposes, infinity, which basically means to the end of the rank list. And we've got a G sub k. This is what we say our gain is. We're going to be accumulating it as we go down the rank list by summing it up. And we have a D sub k, and this is our discount at rank k. This is the general form. And you can see the time-biased gain follows this manner. So we ended up with a G sub k that we had, and our discount was based upon, again, our prediction of the amount of time it would take someone to reach that rank and what fraction of people are still searching at that time. And so, yeah, you're not going to gain the gain if you're no longer searching anymore. You basically, that fraction of the population has stopped searching. So this is the general form of these. One thing that was missing from ours was a normalization. We did not normalize it. And why should we actually? The moment we start to normalize it and try to get it between 0 and 1, what does that really mean? I actually prefer the notion of, yes, this gives me back values which are understandable. These are the predicted average amounts of relevant documents people will find. All right. So we tend not to normalize time-biased gain, although we have in the paper, we talk about how that could be possible. Whereas NDCG is very frequent, is almost always normalized. If you didn't, it's just discounted cumulative gain. So we're just going to sum up the gains and discount them as we go down. The notion of the discounting, again, the one thing to note is that this is absolutely based upon the observations that people had, which is as people go further down in rank lists, we see fewer and fewer of them clicking on documents. Likewise, we know as they go that people are looking at, they're not looking further down the rank list. Their actual examination patterns tend to fall off. They tend not to just keep looking for stuff. They're going to stop at some point, and if they haven't found what they're looking for, they go up and they put in a new query, or they quit and leave the search engine. So this is, the nice thing about this formulation is it's based upon reality. So this has embedded in it, this is one of the big shifts when this was invented, I think it was around the turn of the century, yes, we actually have paid attention to what users are doing and captured it here in our evaluation measure. Now, this is not the measure, but the idea of putting a discount by the rank absolutely comes from observing users and trying to put that into the model, to have a more accurate model that reflects actual user behavior with search engines. Now, let's actually show you the discounted cumulative gain, and then we'll get to the normalized discounted cumulative gain. So DCG, so the discounted cumulative gain at rank K is equal to the summation of I equals 1 to K. The gain, this is the gain at rank I divided by log base 2 of 1 plus I. So this is our discount. Okay, so again, we have a cumulative gain methodology. I want to make a note here that this is not the version that's in the original paper. I am guessing that this is the version that has taken form over time. Okay, and so hopefully this is the standard one today, and what I'm trying to get at. There is another formulation. You see it in the textbook and you'll see it on the web. It involves squaring of the gain. But this, you could again say that there's all sorts of ways of having this, but yes, you'll see formulations where they've squared things and so forth and so on. So there are variations, and be aware of that. You always want to know, so how did you actually, what is the actual NDCG that you're actually using in this paper? Sometimes it's just simple as citing and saying, I'm using this piece of software to calculate it, so that everyone knows that they can go look at that piece of software and find what the formulation actually was, so that they can reproduce it. Otherwise, you can produce different scores. So there are different versions of this floating around out there. So we want to make some notes about the gain. So the gain at I is greater than or equal to 0. It's not just 0 or 1. So this is one of the biggest things that what came about was to say, we're not going to just talk about a notion of binary relevance, so not relevant and relevant. We're actually going to start to say that there are different values to documents. Now, I've been stressing earlier that, yeah, a number of relevant documents found is something that we can absolutely sum up. I actually think it's a little problematic to talk about summing up gain values. So for example, you'll have common schemes that are employed where you have, say 0 is non-relevant. We're going to say 1 is relevant and 2 is highly relevant. There's another scheme. So schemes that like reported that Microsoft uses is for web search is 0 is non-relevant. 1 is marked as a poor document. 2 is a fair document. 3 is a good document. 4 is an excellent document. And 5 is perfect. But with the caveat, actually, that perfect is reserved for navigational queries. So if it is or a navigational result for a query. So only the navigational result for a query. So if I type in University of Waterloo, only the one that takes me to the home page, only that result would get a gain of 5. And other really great pages at the University of Waterloo could at most only get a 4. And this is put into this scale is with regard to web design, trying to really emphasize that these are very important to get right and they should be ranked very high in the ranked list. Anyway, but the real thing is you look at this and it's like, well, if I get 3 poors, is it worth 1 good? It's questionable whether it makes whether truly there's meaning to summing up a bunch of poor things versus, some other quantity of things up here. 5 is more than 4, but it's just because it's a special class. What ends up happening here even is just that, I'm just trying to be sure that I explain to my ranking evaluation measure that I want this thing on top. There are potentially other ways and other measures. For example, there's a new compatibility measure that Charlie Clark has that I also have been involved in as well, but Charlie's invention. And replacing this idea of gains with actually, let's pay attention to preferences. I prefer this document to that document. If there's time in the course, I'll come back and we'll talk about compatibility. But while I'm talking about there's a little bit of strangeness there, I think it's important to actually make it clear, like, NDCG is widely used, widely accepted, and it works really, really well. Okay, so it is a good measure. I'm not trying to talk trash about it at all. Now, so that's the discounted cumulative gain. We're missing our normalization here. How do we get to our normalization of this measure? All right, we're going to go and solve it as follows. And this is something that students get a little confused on, so let's spend some time on it. All right, so what we do is that to normalize, we compute what is known as the ideal DCG. So what's sort of the best DCG that we could get? Now, what do we mean by that? Now, what this means is to go ahead and pretend that we're ranking things, and we're going to rank all the relevant documents first in a ranked list. How could we do that? Well, again, we have the relevance judgments in our test collection. So let's just take those documents and order and put them at the top. It's supposed to be relevant documents first, and with the highest gain before lower gain. So we want to see the ones that have more gain ranked before the ones that have lower gain. Basically, the better relevant documents before the less good relevant documents. So let's take an example here. So let's say for a given topic, we have the following things. So for a given topic, we have the following. We go look at our relevance judgments, and we have gain, and we have the number of documents that fit that. So at gain 5, by definition, we should only have one document. It's the navigational result. There's only one document that's perfect. Rank 4, there happen to be 3 documents that we know that are excellent. 3, which is, I think, good. There's 6 documents, and at 2, we found 10 documents, and at 1, we found 30 documents. And at 0, which is non-relevant, there's basically an infinite number of documents. We don't really need to worry about this, and we actually don't. We will never actually rank the non-relevant documents. We only care about how to order these. And so what we do then, we can take that knowledge with those documents, and we can end up with our ideal. So if we wanted to, if we had an oracle, and we could say, what's the best way to order these? Well, this is going to look like as follows. What's the ideal? Well, we know what is judged to be relevant. Let's just put it in the right order. Let's put the rank 5, 1, then the rank 4, 3, 2, and 1 as we go down. And so we would have at rank and a gain. So at rank 1, we would put the document that has gain 5. And then at rank 2, 3, and 4, go the next 3 documents, which are all, rank 4. Say 3 and I write 3. I mean to rank 4. All right. So now we've got 6. So now this takes us at, 5, 6, and I'm not going to do it. But then we would go ahead and put the rank 3s, on down. Then we'd put the gain of 3s. Then we'd put the 10 documents of 2, and then the 30 documents of 1. And so this would be our ranking. And we would know that at this rank, we have these gains. And then basically, we're able to take this thing and you put it into DCG. So you run DCG on this ranking, and this is equal to the IDCG, which is the ideal DCG. So this is the highest score that we could get for this topic with discounted cumulative gain. We've put the very best stuff up the top, and as we go down, things are discounted more, but they're worth less. And so this maximizes our summation of the gain if they had been in this value, in this order. All right. So once we have that, and it's on a per topic basis. And so then the normalized DCG, which was, so we can get to the original name, the normalized DCG is, so NDCG is then equal to, when we compute DCG, and we divide it by the IDCG. So this is on the actual search results, and these are on our ideal search results. And that normalizes it. And so we'll get a value always between 0 and 1, because the best anyone could ever do is the ideal. So what were some of the big things to know about NDCG? It is a very important measure. 1, its use of graded relevance. This was actually a big step, going from just binary relevance to graded to actually saying, I want some way to note that I think these are better documents than these documents. It's a way of basically expressing some preferences, but it's not, so there are preferences there, but the measure itself only captures that preferences by, in the notion of what's the best ordering. Again, it doesn't necessarily make sense always really to be adding together these gains, but nevertheless, in general, if you're going to score high, you should order things in a similar fashion to how it goes ideally. All right, so so this was a big change to measures when this was introduced, and it's an important thing about it. Super important. The user accumulates gain, which, you know, it is a notion of user behavior. As I use the system, yeah, value accrues to me if I'm finding relevant material. That's reflective often of real systems as well. And it's a measure base. It's a measure that's similar to the notion of just how many relevant documents I'm finding, but it's trying to give more value to finding better documents versus lower quality documents. And so again, I like the fact that it's based upon the user. This is based upon our notions. It gives, what users actually value. And then finally, the discount reflects that users do not all reach the same rank. In other words, as you go down a rank list, fewer and fewer users travel further down the rank list. Again, this is based upon observation, and it's wonderful. And so a lot of NDCG is based upon, let's pay more attention to the way users are actually searching. And let's come up with a measure that's more reflective of their actual behavior and how they might potentially value the system. So these are all really great things, and certainly a revolutionary measure. Now, while it's inspired by user behavior and based upon the observations, so it's inspired by real behavior, but this version certainly is not calibrated. Okay. And it does not account for summaries and the user interface that we were talking about previously. Okay. Likewise, I can just continue on. It's all the features that we had in the last one, nor the notion of different time to read documents, etc. So there's a whole bunch of things that in the time-biased gain, it's like we're going to pay more attention to the user so that we can hopefully make more predictive results and have an evaluation measure that allows us to better distinguish between different search systems and to also incorporate important features of the user interface into that evaluation measure. So there's a lot that's here that's based upon users, but yeah, I mean, we came out with our time bias gain more than a decade after, I think, than NDCG, and so yeah, we had some more time to try to figure out some more ways, and people have continued on, and there's more things that people are doing to model user behavior that's more reflective of their actual behavior. And so I think NDCG, it's still a workhorse. It's still used a huge amount. It shows its value to the industry and to people. So it's held its own. And then we're all working together to basically try to keep coming up with new measures that are able to capture the actual user behavior and make more refined ability to predict performance of search engines in an offline fashion, where we use our test collections that are predictive of what's actually going to happen when you actually deploy it with real users. All right.